Hey everyone, so we are now in section P6. Section P6 is all about rational expressions. So rational expressions, we're talking about a fraction that is made up of a polynomial divided by a polynomial. And so in this video, we are going to be talking about these main objectives. First, we're going to specify numbers that must be excluded from the domain of a rational expression. We are going to be simplifying, multiplying, or dividing rational expressions. We are going to be adding and subtracting rational expressions, and we are going to be simplifying complex rational expressions. Lots to do today. I don't want to make this video too long. I will try my best, but let's get started. So, first thing we want to talk about is a review on factoring. This whole section, when we talk about rational expressions, we need to be able to factor. So just quick review here, because it might have been a while. Remember, factoring, we need two numbers that multiply to the C value and add to the B value. So I need two numbers to multiply to 5. That's got to be 1 and 5. And they add to 6 as well. So that's awesome. That's my factored form. This is the standard form, factored form. They do the same thing, mean the same thing. They're just written in different forms. We have a difference of squares here. If you remember, a difference of squares only happens when we're subtracting two perfect squares. We know right away it's going to be x plus 5 and x minus 5 because 5 is square root and x squared I can take. 25 is a perfect square. That square root of 25 is going to be 5, and the square root of x squared is x. Okay, so let's check out here some definitions here to remember. A rational expression is the quotient of two polynomials. The domain is the set of all real numbers for which an algebraic expression is defined. So domain is your possible x values. We have to remember that we have to exclude numbers from the rational expressions domain that make the denominator 0. We know we cannot do 5 divided by 0. Your calculator is going to give you an error. So for the same reason, like if you saw 5 divided by x can be any number. X could be 1, 100, 300, but x cannot equal 0. And that's the domain that we're going to talk about. Two different forms we're going to write it in. This is what I just wrote it in, x cannot equal 0, or interval notation. Interval notation uses intervals with grouping symbols. So we're going to give you an example for this one. Interval notation, think about infinity. We go on a graph, goes on forever in the negative direction and the positive direction. So this graph goes on forever, starting from negative infinity, and we have to exclude 0. So we get really close to 0, and we put a parenthesis, and then that union, that's supposed to be a U shape, union goes all the way to infinity. Okay, so that interval notation says this graph goes all the way from negative infinity. It gets really close to 0. It doesn't touch 0, but it gets really close to 0. And then we skip over the specific number 0, and then we continue on to go towards infinity. The parentheses are there to say it gets really close to that number 0. If it was a bracket, that would mean it touched 0. We don't want it to touch 0 because that would make this graph undefined. Okay, so let's determine the domain of each of these equations here, expressions. 4 divided by x minus 2. So it's helpful to set that denominator equal to 0 to figure out the issue, right? Then I'm going to solve, and I now see when x equals 2, my denominator equals 0. That's going to be my domain. X cannot equal 2. In interval notation, we go from negative infinity all the way to 2, skip over 2, and continue on. Let's check it out. Check out B. I set my denominator equal to 0, and then I'm going to factor this. So then I know x is going to equal plus or minus 1 when it's 0. This is my domain restrictions. It cannot equal a positive or a negative 1. When I write it in interval notation, I have to set up a really long one of these because I have to hop over two numbers. So we go from negative infinity, we go from left to right, so negative 1. And then I'm going to go from negative 1 to 1, least to greatest. And then I have to go skip over 1 and keep going towards infinity. Okay, that's my interval notation. And then let's check out C. I'm going to set my denominator equal to 0, and I'm going to factor this. And then I know x cannot equal -6 and +3. Those are the numbers I have to exclude from my domain. So we're going to go -infinity to -6. And then I'm going to go to -6 to 3. And then I'm going to go to 3 to infinity. And that's my domain. Let's check out now simplifying rational expressions. So in order to simplify rational expressions, we're going to follow these steps. First thing we want to do is factor the numerator and denominator. And then we are going to divide both the numerator and denominator by any common factors. That means we're going to do a lot of canceling out. And then we have to remember also to state the domain. And we need to state the domain before we cancel out any common factors. State domain before canceling common factors, because they still impact the original expression. So let's do some factoring here. X squared plus 6x plus 5 will factor to x plus 5, x plus 1. X squared minus 25 is going to be x plus 5, x minus 5. Here, I'm going to look at my denominator, and I know that x cannot equal plus or minus 5. Those two numbers will make the denominator 0, not allowed. So I stated my restrictions, and now we will cancel. So what is left over is x plus 1 over x minus 5. That's our final answer. Let's check out multiplying rational expressions. Very similar. Factor numerator, denominator, do any canceling, and then you multiply straight across. Again, state domain before you cancel. Multiply straight across. Whatever is left over. Okay, so let's check out this first one here. Factor whatever we can. So we're multiplying, notice, and I'm going to just kind of create one long fraction, multiplication of fractions, you go straight across. So I'm going to have x plus 3. I'm going to factor this. We're going to have x minus 3 and x plus 2. And then we're going to factor your denominator, and there's lots down here, x plus 4, x minus 4. And then I'm going to have x plus 3, x plus 3. When I factor every piece of this original expression. And now I'm going to state my domain. X cannot equal plus or minus 4 and negative 3. And then we'll be able to cancel out some common factors here. Oh, I'm sorry. These should be 2's. Right? X squared minus 4. That'll give you the difference of squares. Forgot to take the square root. There we go. Now we'll cancel out any common factors. So I've got x plus 3 here, x plus 3, x plus 2 with 1x plus 2, and that's about it. So what we're left with in the numerator is x minus 3 over x minus 2 times x plus 3. There's your answer. Here are your domain restrictions. Now let's check out a division. Now remember, when we multiply fractions, we go straight across. When you divide fractions, you multiply by the reciprocal, okay? And that should sound familiar. A lot of times you learn keep, change, flip, or keep, flip, any of those little acronyms there. So we're going to keep our first fraction the same. Let's factor that while we write this down. So I'm going to have x minus 1, x minus 1. Let's start to write 1 over, I'm going to take out a GCF here of x. Take an x out of x, you'll be left with 1. I'm going to flip this second fraction. So actually, let me write this separate for now. So now I'm going to multiply by 3x squared plus 3 over x squared plus x minus 2. And so now we'll factor that second fraction after we have flipped it. So I'm still going to have x minus 1 over x times x squared plus 1 times, we'll take out the GCF. And then we will factor down here. That's 2. And now we will state our domain restrictions. X cannot equal 0. That x squared plus 1 gives you an imaginary number, so we don't need to worry about that one. 1 and -2. It is important that when we state our domain, we are looking at the numerator and denominator of that second fraction along with this denominator of your first fraction, because notice at one point both of these expressions were in the denominator. So we need to check both of them. Okay, and so notice if I check both of them, this is still our domain restrictions. And now we will cancel anything that is a common factor. X squared plus 1, x squared plus 1, x minus 1, x minus 1. So we are left with 3 times x minus 1 over x times x plus 2. And there's our division, there's our quotient to this problem. Okay, let's check out adding and subtracting rational expressions with different denominators. So in order to add and subtract regular fractions, not even just rational expressions, we need a least common denominator. Okay, so it must be found in order to add and subtract rational expressions. In order to find the least common denominator, factor each denominator completely, just like we've been. Second step, list the factors that have in common and the ones that don't as a product. Okay, so let's see what that means when we look at this example. If we, to find our least common denominator, let's factor denominators here. So I'm going to have x minus 3 and x minus 3 for this denominator, and this denominator is going to give me x plus 3 and x minus 3. My least common denominator, I have to list all of these factors that both have in common. So I'm going to list the x minus 3 here. And then anything they don't have in common. I need the x plus 3. And then I need another one over here, x minus 3. Okay, list all of the factors that they have in common, and then list all of the factors that they don't have in common. Just one of each. And then we can also write this as we can also write that as x minus 3 squared. That's my least common denominator. So we need to be able to find least common denominators in order to add and subtract rational expressions. Very first thing here, let's figure out what the LCD is. The least common denominator, because this is already in factor format, I can just go right to the least common denominator. State any factors in these denominators that they both have or they both need. So I'm going to have x minus 3 and x plus 3, one of each of those factors. And just a side example, think about if you were adding these two fractions, our least common denominator, is 6, but it's because I listed both of those factors and I multiply them together. So that's where it comes from. Same idea. It's the same idea. And now we multiply just like we would over here. I can erase that too soon. Over here, I would multiply this by 2, and over here, I would multiply this by 3. You multiply by the missing factor. So I'm going to multiply this one by x plus 3. Whatever I do the numerator, I have to do to the denominator. And I'm going to multiply this one by x minus 3. Multiply by what it's missing. So then I'm going to have in the numerator x times x plus 3 plus x minus 1 times x minus 3. And I'm writing this as one big fraction now, over my common denominator x plus 3, x minus 3. And then we'll start to simplify. So I'll multiply in my numerator. So I'll have x squared plus 3x. Let's do some foiling here. I'll have x squared minus 3x minus x plus 3 all over. Let's keep our denominator in factored form. And then combine like terms in my numerator. So I'm going to have 2x squared. 3x minus 3x cancels, and I'll be left with minus x plus 3. All over x plus 3 and x minus 3. And that's going to be our final answer. Again, we can state our restrictions. It can't be plus or minus 3. And that goes back to the least common denominator. Let's check out this other one here. Notice our denominators are not factored already, so we have to factor them to start. We didn't have to do that with the last one. So we'll start here, x over, we'll factor this, x minus 5, minus x minus 4 over, we'll take out a GCF, x minus 5. And so now we can look at this, my least common denominator. One of the common factors, so it's going to be x minus 5, and anything that it's missing. So I need the 2 here, and the other one needs another x minus 5. And so we'll multiply each fraction by what it's missing. So that first fraction needs to be multiplied by a 2, and the second fraction needs to be multiplied by another x minus 5. So now we'll have 2x minus, in your numerator, x minus 4 times x minus 5. All over in your denominator, we'll have our least common denominator 2 times x minus 5, x minus 5. Let's do some simplifying in that numerator. So we'll have 2x minus, I'm going to keep this in parentheses because of that subtraction, x squared minus 9x plus 20. And now we're going to keep this over our least common denominator. And we'll distribute that negative now. 2x minus x squared plus 9x minus 20. And we will be able to combine like terms. So I'll have, and write this in standard form, negative x squared plus 11x minus 20 all over your least common denominator, 2 times x minus 5 squared. There's your final answer when we subtract those two expressions together. And our domain restrictions, going back to our least common denominator, it just can't be 5. Okay, and then one last topic here to talk about is complex rational expressions. This just means that we've got fractions and fractions. It makes it complex. So it means have numerators or denominators containing one or more rational expressions. To simplify complex fractions, combine the numerator into a single expression and combine the denominator into a single expression. Then perform the division. So we're going to check this one out. So our steps, combine the numerator, combine the denominator, and that's what we're going to do. So let's just focus on your numerator. Let's zoom this in. Maybe I'll just go like this. That's all you want to focus on. What's our LCD here? Is going to be 2x. So I need to multiply one of each of the factors, and there's nothing in common. I need to multiply this one by 2. I need to multiply this one by x. So our numerator is going to be 2 minus 3x over 2x. Not so bad. Now we're going to look at just the denominator. Get a different color here. What's our least common denominator going to be? One of each of your factors, so it's going to be 4x. Multiply this fraction by 4 and this one by x. So we will have 4. So all of this is going to be over another fraction. 4 plus 3x over 4 plus 4x. So we've got a fraction divided by fraction. Notice now we can write this as 2 minus 3x over 2x divided by 4 plus 3x over 4x. And we know how to handle that. We know when we divide fractions, we need to multiply by the reciprocal. So now we're going to do 2 minus 3x over 2x times 4x over 4 plus 3x. And that's our problem. We're going to simplify where we can here. So 2 minus 3x times 4x. Notice we can simplify 2x over 4x, right? 4x here, 2x here, 2x and 4x. Those x's are going to cancel. And this 2 will go into the 4, and we'll have 2 there. Now what's left in your numerator is 2 times 2 minus 3x over 4 plus 3x. And nothing can be simplified further. We can multiply in that too, 4 minus 6x over 4 plus 3x. But we can leave our final answer like that. We can't cancel those 4's because we're adding and subtracting. Great job on this lesson, guys. There's things to talk about. We have now added, subtracted, multiplied, divided rational expressions, and even looked at complex rational expressions. If you have any questions, send them my way. If not, great job, guys.